Alrighty, guys. Howdy. Thanks for coming in today. Seems like anymore. We don't get people when it's nice and sunny out. We don't get people when it's rainy out. I don't know what weather we get people at, but appreciate you guys coming.
Yeah.
Finishing up our conversation about glaciers and sort of segueing into a little bit about the ice ages. I know we talked at the beginning of this a little bit informally about ice age stuff without any actual slides up, but we'll get a few slides going here by the end of today.
Yay.
We're going to, excuse me, next Tuesday, we're going to watch that video that I mentioned. There is a worksheet that goes along with it, a little incentive for lack of a better reason or a better word, to come and watch that video, get some points for the worksheet. But and then after that, we'll have time for one last conversation that following Thursday. Semester is wrapping up quickly. What's that?
Next Thursday, next week.
Not today, yeah.
Okay.
Yeah. So semester is wrapping up very quickly, and then that following Tuesday will be test number 4. So we've been talking about a number of things, be it weathering or erosion, and we mentioned that in environmental science, such as this, we don't really focus on that so much as if it were a geology class. But weathering and erosion are still a function of what's going on here at the surface of the Earth. They affect lots of different things. So, well, we've been talking about glacial deposits, the moraines, the eskers, the so on and so forth, drumlins. Now we're going to talk about, we're going back to weathering a little bit. But these are still a feature. So, under the subject of features, we're still under that topic, but the cause of the feature is weathering, not depositional. Glacial grooves. Might be a little hard to see what we're actually concerned about in here, but you might see some lines, some striations, some bright spots moving across the screen from sort of the upper left to the lower right. All right. And these are what's called glacial grooves. They could be absolutely any size, but for us to actually notice them and not plow over them, dig them out, put a building on top of them or whatever, usually they end up being anywhere from, the size of maybe pencils. Think of the chalkboard kind of thing up here, where it's got to be that nice little indentation there that can hold a piece of chalk, or as I said, a pencil. Upwards as big as, well, again, as Mother Nature can do what she wants. Glaciers can carry any size boulder, but I've personally seen these as big as, like you could run a toboggan through them. What happens is, remember we told you glaciers pick up lots of junk as they're moving along. And glacial grooves happen when rocks get stuck out the side of it, and you're grinding over, very, very slowly grinding over another surface. It's basically like a key job, okay? Keying a car. Not familiar with that?
No.
Good. You should be. It's a horrible thing to do. So a great big scratch or a scrape, okay? And like I said, they're not really horribly important in the traditional sense, but they're really cool to see as like I said, remnants of a time gone by. And as I said, often they're so small that you don't really they don't get noticed. This is from Kelly's Island, which is up on Lake Erie. It's one of a handful of touristy spots up there. Kind of like you guys have the Thousand Islands over here. There's the South Bass Islands, and Kelly's Island is a part of that little chain up in Lake Erie. Whoever happened to be up there excavating, all right, as part of that crew, happened to notice, called the foreman over, whatever happened, and they didn't destroy these, when they were doing whatever development they were doing decades and decades ago. You can't get super close. They're surrounded by chain link fence, sort of that natural heritage kind of thing. But again, these are as big as those big old-fashioned metal slides that are slowly but surely disappearing from the surface of the earth. Or as I said earlier, a toboggan. You know, you could easily run a great big sled down these things.
What's the toboggan?
A toboggan is a kind of sled.
Oh.
Yeah, no worries.
Yeah,
The glaciers definitely, you know, came over the Great Lakes, changed those from what they were. And like I said, when there was solid rock in the way, it was very easy for the glaciers just to mangle and mash them into whatever they needed to. So glacial grooves. We also talked briefly about calving the other day. Calving, depends if you pronounce the L or not. It's up to you.
Calving. Oh, that's easy to say.
Sorry?
Calving.
Yeah?
Yeah, that's pretty easy.
And it is the process of icebergs breaking off, okay? Ice sheets will hang over, and the stuff is, you know, you're in the zone of wastage. Stuff is melting, stuff is breaking, and you get these big old hunks of ice coming off. And what we're adding to the mix here now is that, believe it or not, you get this preserved in the rock record, these drop stones. And what happens well, I'm saying again a lot, I apologize. Remember that these glaciers are chock full of all kinds of sediment that not only have they drove over, but they've ground off of other things. Anyhow, as that melts, they literally plink, 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 kind of melt out of the ice and leave sort of just a scattered. Now, how they can tell this random distribution from something else, I have no clue. Maybe they put it together with the fact that, okay, we know there's moraines here, we were just offshore, these must be blah, 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 okay? Because obviously it's got to be random. There's not going to be a pattern to this. So, you know, recognizing it in the rock record. Again, I'm guessing you're going to have your typical think offshore. You've got muds, okay?
Oh, wow.
And you're going to have this random distribution of, well, rocks. You know, things definitely bigger than silt and clay, which is what mud is made out of. So, again, there's probably some way of looking at it, or even if it's sand and not just the silts and clays of muds. Yes, sir?
How can they actually move around the iceberg?
Can they do what?
The rocks and sediment and stuff. Can that actually move around the iceberg? Or is it just like keep in layers and layers?
So, underneath it, or I don't know, you said...
Like underneath it, because it picks it up from under the ground. Off the ground.
Okay, and is it moving the... No,
I mean...
I guess I'm not understanding the question. I apologize.
Is stuff moving inside the iceberg?
Oh, no. I think it's more like...
It's picking it up and replacing.
No, not even that. I mean, it is... there is some turning around. Remember, as the ice is coming down the slope, it's not just sliding. Like, to go back to the sled analogy, it's not just sliding like you would in a sled. There is some flow within there, and it does get picked up and brought more into the middle, so to speak. Yes, that is definitely going on. But when this stuff melts or drops out, it's really just coming out of, you know, because even though that water is super cold, it's not ice. So that iceberg is melting very slowly, and as that happens, these things are kind of falling out of not even suspension, but falling out of, you know, the ice itself. Kind of like if you went to, I always have the food examples, but if you went to the ice cream store or whatever, instead of just getting a chocolate milkshake or a vanilla milkshake, you got a chocolate chip cookie dough one or something like that, okay? And for most of the time you're drinking your shake, everything's all mixed up, but slowly but surely you're going to get that pile of sludge in the bottom. You know, that's all that cookie dough and stuff that won't come up your straw or whatever. So, yeah, basically like that.
Okay.
Yeah. So they just call those drop stones, and again, calving is the process of forming icebergs. my favorite, just because I really like to say fjord. That J comes off like a Y. Okay, picture IKEA. If you've been to IKEA, they got a lot neat ways to pronounce things there. So a fjord is an inundated glacial valley. Well, what the hell does that mean? Well, remember, we only got so much water, right? So when you want to make giant sheets of ice from the North Pole to New York State, that water has to come from somewhere. Where it came from was the oceans. So because sea level is a lot lower, all our rivers flow a lot farther. Rivers still do what rivers do. They make valleys. And then as sea level comes back up, well, those old river valleys, picture the Mohawk Valley, for example, those old river valleys flood. All right? And what it turns into are really, really beautiful scenery. Again, not, traditionally what we would call important. But if you were to go on a cruise ship and cruise the North Atlantic, they're going to pull into 3 or 4 fjords because they're that stinking beautiful. Going back to days of lore, these were definitely ports that you would want to be protecting. You'd have all your people stationed up on top and just rain all hell down on the ships coming in below. And it'd be really hard for them to shoot you, kind of thing. It's just, well, I'm going to show you a picture in a minute. Just big, beautiful inlets, and again, stuff like that. And the glaciers also went further down. Not even just rivers carving valleys, but glaciers carving valleys. The shape here is reminding me that this one in particular is, carved by a glacier. If sea level's further, the glaciers are going to go further. So when that all melts out and dies down, sea level comes back up. Got a nice little village down there. But, and like I said, if nothing else, very fun to say the word fjord. So that's a nice segue into talking about the last ice age. That is the majority of what we see at the surface. When geologists go in and look deeper down into the rock record, we see evidence of this happening time and time and time again. There's been, I'm just going to say a half dozen, I don't know the exact number, several major glaciations, ice ages over the years. The Earth has been here 4.5 billion years. Okay, we don't even have records of all of them, I'm sure. But we've certainly seen evidence of many of them. So what we got here, this is lacking state lines, which makes it difficult to see exactly where you are. I always use the Great Lakes to position myself, though. And you see all those little red scribbles over towards the east there. Those are sort of showing you where, those are the moraines is what it's saying there. But that gives you an idea more or less of, and I've got a better picture coming up in a minute here, of where the glaciers went to. Oops, stupid watches talking for me. You also see on here Lake Bonneville over to the west. All right, you don't hear too much about Lake Lohania there, or Lohanta, I can't tell if that's a T or an I. But everyone knows Salt Lake in Utah, all right? That is a remnant of Lake Bonneville. And Lake Bonneville formed when a big old ice dam, which is exactly what it sounds like, all right? A big hunk of ice was blocking up a whole giant lake full of water that had already melted. It broke free. And again, how are they figuring this stuff out? They actually go back and they'll see these flood deposits. Same thing we see associated with floods today, but we find them in the rock record, and they kind of piece this stuff together like CSI. When I'm talking to you guys about this stuff, I get, I don't say confused, but I forget that we haven't just spent an entire semester talking about geology like I do in my other classes when we get to this point. So you guys don't necessarily have all that behind you, but these things leave signatures, if you would. So Great Salt Lake is really just a remnant of Lake Bonneville. that was around in the post-glacial days. Again, the Great Lakes looked a bit different back then. There was more water in them, for one thing. Yeah, let's just flip to this as a little better idea of what's going on here. Still no state lines, but this gives us an idea where the ice sheets were. Okay, and it wasn't just North America. It was all around the northern hemisphere that we had this glaciation going on. And then you even see a bit of alpine there over in the Rockies there in the lower. Finger Lakes, you guys are familiar with, hopefully, if you grew up here at any rate. They were streams, rivers that connected to Lake Ontario, and pretty sure it was Ontario, not Erie. They're not far enough west to have connected to Erie, I don't think. But they got, it's funny, in some parts they got completely clogged up with sediment, filled in with sediment, and then in the other part they got gouged out even more. All right. If you've been down the Ithaca Way, you guys aren't really old enough to go over there for wine tours yet. You may have, though. But you go down Ithaca Way for hiking, I found a lot of you guys are familiar with the area for that reason. Ithaca is gorgeous, as they say. The gorges over there are amazing. And the whole area is very, very glacial. It's another reason we're taking some time out on Tuesday to watch this video from the gentleman up at Oswego State who did the. What was funny about that?
Sorry.
That's all right.
Is that rude?
Well, no, I just wondered what was funny. Out of our time, so you guys are familiar with a lot more of what's around you, around the landscape, and the fact that it is glacial in many, many, many cases. So it's a good use of our time. But at any rate, the Finger Lakes used to be rivers. All right, so this is a neat map. And I'm sure this has been modified 6 times since it's been published. Because science is science. It's always moving on. It's always, I don't want to say progressing, because sometimes there's a little bit of regression going on. But it's always getting more data. All right? And from more data comes new thoughts and ideas. So the first thing we want to look at is not the flooded North America here, but the other lines. We just got done talking about when the sea level was lower, how that brought our coastlines out farther. So you look at New York, that red dot over there, and we want to look at that lighter blue area just to the right of it, just to the east of it, and New York would not have been a port city at that point. Okay, again, when are we going back? 10,000, 12,000 years ago. Maybe to 15, depends. All right? And it depends that I just don't have that information. I know it varies 10 to 15,000 years-ish. That you would have gone, arguably another state's worth of land, especially over there. There's such tiny little states, to get to the coast. Okay? All of your favorite beach cities were inland. All right? Anything Outer Banks, those sandbars didn't even exist yet.
There's a TV show called Outer Banks.
Cool.
Yeah, very cool.
So the coastline was way lower. So instead of just me saying way lower, now you can actually see where it was. Now we take it back to our current coastline. That's the second black line there, and the slightly darker shade of blue. And it should all be green, of course, because at the moment Florida is not underwater, for example, and Virginia, and the good bits of your Carolinas and whatnot, let alone Texas and all the way up into Tennessee. There, that's all dry at the moment. But they're shading it blue because of the next line that we're going to be talking about, which is if the ice sheets continue to melt. Now, again, this has become such a political thing anymore, and that's a damn shame. Science shouldn't have anything to do with politics, but it does. So what we need to think about then is, okay, let's remove that from the conversation, and while we might find it ridiculous that the ocean can go all the way up to Memphis, whether you not know where Memphis is, you do know it's in Tennessee, right? And we do know, of course, that the Tennessee at the moment is not exactly coastal, right? Not beach. So let's extrapolate out there a little bit again if we're finding this hard to believe, and let's think about the rocks we have here in New York State, where we are. All right? We are surrounded by, underneath us, limestone. Limestone full of marine fossils, marine critters. All right? It's all around us, all the way over, not just us, but all the way over to Ohio. Well, Pennsylvania first, then Ohio. Before the glaciers, all right, way back when, I forget exactly, almost 300 million years ago, right between 200 million, 300 million years ago, this was flooded all the way up, all right, giant inland sea, basically between the Appalachians to the east and the Rockies to the west. It was all flooded. It was all marine. It had sharks swimming around in Kansas. Okay.
Actually,
So yeah, I mean we've got the rocks there with the fossils there.
wait, sharks
So-
swimming in what, right?
The ocean came up through the same depression area that we're talking about right here, through the Gulf Coast, and up through where essentially the Mississippi is, if you can picture that maybe, and then out to either side. Okay,
And
was
when
it
did this happen?
giant inland sea? Around about 250 million years ago-ish. It might have been. My dates are off. Yeah, not recent by any means.
Yeah, never mind.
Yeah, no. Long time ago. Might even be in the 350. I apologize. My brain's not retrieving those numbers at the moment. But we know what happened.
Yes.
So to say that, it's going to follow that same path again isn't really even a difficult guess. The question is how much water this time. So this is probably a bit of an exaggeration, I hope. A lot of times, and this is why you have to take, whatever side of the news you're on, you have to take both sides with a grain of salt. Remember, a lot of it is sensationalization, okay? And they need to get viewership, they want to catch your attention, so on and so forth. Scientists are not, again, they're supposed to be removed from that, and their data is their data, but this is somebody interpreting somebody's data. How many times is it removed? Okay? So for all we know, and again, I'm not downplaying this, please don't get me wrong, I'm just trying to teach you, remind you that you need to think critically. This could have been somebody's diagram that said, worst case scenario. And somewhere along the lines in translation, that part got lost. So, at any rate, here in Utica, we're not going to be coastal, unfortunately. That would really be nice for the property values. But again, just take a moment and look down there and think about some of the places you might have driven through and so on and so forth as we move down the coast there. And that will slowly but surely flood over. And that's not even looking at the West Coast, let alone the rest of the planet. Places over in Europe are already experiencing this more than we are.
Where exactly?
That's a great question. Over in Holland and whatnot. Again, we might have a bit of subsidence going on as well, to go back to one of our other terms. But they're definitely experiencing this. Florida, many of the areas there. Again, whether their governor will acknowledge it or not, the cities and towns are fighting because they're at sea level. At sea level, and much of Manhattan is not far above sea level. Again, next time you're there, I encourage you to go one side of the island or the other, or all the way south. It's up to you. It is not far above sea level. So, and I imagine the Thousand Islands, that whole St. Lawrence Seaway, will be a whole other thing as well. So we might see some flooding. We'll see. We'll see. You know, Oswego, areas like that, Mexico up there. But Mexico's a little south maybe, but
Mexico's right below us.
yeah, no, the town up in upstate.
Oh yeah, never mind. I know what you mean.
Yeah.
I know that place. But we have Mexico, Russia, Poland.
Yeah, Russians up there.
Amsterdam, Rotterdam.
Yep, we borrowed a lot of names.
Yeah.
Borrowed a lot of names.
Yeah.
So, he was asking me when did this happen, and this is not the inland sea. That was me just going out on a tangent. I apologize. But the Ice Age, in quotes, okay, and we talked about this the other day that you guys saw in the movies. That is called the Pleistocene, all right? I don't know if you guys in any of your probably earth science in high school have come, huh?
I took earth science.
Good. Have come across the time scale, okay, geologic time scale. There's a lot of Ocenes and whatnots in there, this period and that period, and this epoch and that epoch. So epochs are one of the smallest periods of time, and it goes bigger all the way up to like eras, right, on the other side. So, bless you, yeah. So the Pleistocene was the most recent ice age. It began about 1.8 million years ago. I hate decimals, so I usually conversationally just say about 2 million years ago. All right. And this 11,700, as I said, that is.
Oh yeah, right. You rounded up to. Yeah, it's 2.
11,700 is really area specific. Okay. It really depends how far south you were when the glaciers were last here. The further south, the older you would want to go for when the glaciers left, kind of thing. But it was more or less as portrayed in the movies. Again, sometimes we have Hollywood to thank or despise for what they've done to science. But, you take a little good, you take a little bad, and hopefully it progresses forward. New York State, as you guys may or may not know, is fairly famous for its mammoths and mastodons that every so often get uncovered. We must have been a pretty good place for that. Again, as the glaciers moved back and started to melt out, we saw fairly good biozones, for these critters to live in, niches, whatever we want to call them, and they would move up and into them. And not only, you got the weather changing, getting nicer, a New York spring, if you would, but plenty of water to grow plenty of vegetation and provide, drinking water as well. So critters were able to move farther and farther north again, and we've got some large cats in this picture here as well. Horses. Horses used to be here. In fact, in college, that's what I worked on for my master's, were the zebras, actually, they say. I argued that a little bit because, we can't see the stripes. But some sort of equines, and that were in Nebraska a little over 2 million years ago. So again, they were just south of the glaciers. But all kinds of critters that we really don't associate with here. And the land bridge, was exposed at the time, going over between North America and Western North America and Eastern Asia there. The Bering Strait, Bering Sea up that way.
Yeah. We're talking California?
No, north. North. Go from Russia to Canada, Alaska. I guess it'd be Alaska.
Okay, I get what you mean.
Yeah. So you got the Aleutian Islands up there now. It was solid land. And again, we know because of, fossils. So that was there. And what happened is a lot of the critters went over that we now associate with Asia and Europe and even Africa. A lot of the critters were either hunted to extinction. We certainly did our share. But a lot of them just crossed over. And again, if they were, trapped on which side of the Rockies is a great question, because these guys certainly are mountain climbers, right? But nonetheless, we see that as a mass exodus route there. Again, as the climate was changing, that's a lot of fur for a critter. And as things got warmer, they went to look for colder climates. But that could arguably have been a scene from around here, just about 10,000 years ago. Yeah.
Is rhinos having fur?
Yeah, we had woolly rhinoceri. If you guys ever get a chance, I know there's so many things to see in Manhattan, but the American Museum of Natural History up on the west side of the park is an amazing place for a lot of reasons. But one of the really cool things for you guys to see, and you hardly ever get past the dinosaurs, but get to the mammal hall. And they've got the Cenozoic, which is the era that this period that we're talking about is in. And some of you guys may know Cenozoic is the age of the mammals, but the giant Cenozoic mammals, they've got so many of them there. And again, not just the cool ones like the saber-toothed tigers and all that stuff, but the giant sloths and whatnot. Just amazing critters. All right, that aren't cartoons. And it's neat stuff. So, and it's free. Another good reason to go. New York State Museum has some stuff, and Museum of the Earth down in Ithaca has some stuff, but Museum of Natural History is very worth the trip. So we are now in the Holocene. We left the Pleistocene and we've entered the Holocene. Why and when? Well, when the glaciers left. They drew a line. They decided to draw a line. They didn't make the decision back then, of course. This is us looking back. And it was a significant enough change on the Earth. And that change on the Earth fueled change in the biology. Okay? Because, again, the ecosystems drive the I don't even want to say the abiotic, but just think about everything that we've learned at the beginning of the semester. This is a great application of it. Okay, the environment changed, and that changes the habitats, and that changes what's going on. And we see humans come into their prime here. We even have another step where we draw Homo sapien, really as truly modern humans, in quote, subspecies after the glaciers come through, and we see the demise, of most of those large mammals. We were just talking about how cool they were, and we start basically turning into what we are at the present. We've spent 10,000 years drying out, making rivers and streams and lakes and all that fun stuff, and writing books to talk about all of it. So. All right, so arguably we could have talked a whole lot more about what went on with the ice ages, but it was just sort of a little wrap up for the conversation about glaciers and glaciation. I can't emphasize enough to you guys how much vocabulary, terminology is coming out of this chapter. Again, even with Tuesday's movie and then whatever we lecture on Thursday, you might look back and you say, "Oh, thank gosh, this is only on groundwater and glaciers." Okay, but between the two of them, tons of vocabulary words, tons. So, unfortunately, I don't have the handouts made yet, or I would actually start that movie now. which would be great, because we are running out of time in the semester. But I don't have them. So even though we're only 45 minutes into lecture here, I am going to call it a day, and we will pick up on Tuesday, and well, we've talked about that several times. So
Yay.
let me hit stop here.